Hello, this is the Dream Team's final video report for the Ball and Beam project. Our team is Max Coraggio, Paul Maienza, and Alyssa Sepcic. The image on the top left includes a basic schematic and free body diagram of our system. For our system, we chose to use gears rather than a linkage mechanism to drive our beam. A large gear is attached to our beam in the center and is meshed with a smaller gear that is connected to our servo motor. As the servo gear turns by angle theta, the beam gear changes the angle of the beam by alpha. As the beam angle changes, gravity causes the ball to roll on the beam. The constants and variables for our system are defined on the right, along with our assumptions. From this information, we were able to derive our transfer function shown in the bottom left corner.
Okay, now moving into the design and build portion of the beam video report. As you can see here is a 3D model of the beam. We went with a mostly laser cut approach for the beam and the side panels, the block of wood for the base, and we went with a gear ratio to drive the actual beam. We did this 2.5 to 1 gear ratio to ensure that the micro adjustments that we want to make were able to be made. As you can see, here's a physical picture of the beam. The end stops that we used, you can see here and here, were O-rings, actually, to provide a soft end for the ball to hit. And one more thing I'd like to mention for the design and build portion was right here. The connection we used for the soft pot was a little adapter we bought on Amazon. Electric taped it shut and used solid core wires to route it to our Arduino board. So now we're going to move on to the next portion of the video report, this being the control algorithm. We used Arduino to control our beam and an Arduino Uno microcontroller, and we used a PID v2 library in order to do so. A couple important parts about our code. Our KP, KI, and KD values, as you can see here, was 1.4, 0.01, and 1.25. We decided to leave KI pretty low because as we increased it, it also increased instability in our beam. It would jitter too much when we increase that value. The next important part of our code were our output limits. This -2 and 2 restricted the beam from going more than 4 degrees of range, which was plenty. This value right here, this 54 degrees, that was used to level our beam in our specific configuration. And our algorithm basically worked as follows. This loop right here would read the position of where the ball is on the soft potentiometer, and then it would shoot it back into the PID as an input. And this here loop would set the position of where the ball wants to go, and it would shoot that value back into the PID controller as the set point. We would get an output, which would then output to the servo motor. And it would just loop and loop and loop and loop at a delay rate that we set at 10 microseconds.
We start over here on the left with 3 step functions that are summed together to represent the ball going from 7 inches to 11 inches to 3 inches. They're added together and sent into our loop, which starts off by going through our PID controller, which has our KP, KI, and KD values that were all mentioned earlier in the algorithm. It then passes through the servo and our gears, which is represented by 2.5 to represent our gear mechanical advantage and gear ratio. It's then passed through our transfer function, which represents the ball and the beam. And then once it is passed through there, it is then sent back into the beginning of the loop over and over to represent the ball's position on the beam. And as you can see here, we have our ball on the beam over time. And as you can see, it starts off by going to its first position of 7 inches, which it goes past and settles into that position. It then goes to to its second position of 11 inches, where it goes past and settles into that position. And then finally goes to our third position of 3 inches, which goes past and then eventually settles into that position. Here we have our demonstration video clipped out and sped up a little bit. As you can see, it started at 2 and went to our first position of 7. And then we are now showing it being disturbed, in which it goes back to our 7th position. And then after this, we set the dial to our second position of 9, and then the ball goes to the 9th position, settles, and then we have it waiting 10 seconds.
Okay, now moving into the overall system performance section. One small issue that we ran into when doing the control and test portion of the project was that we realized that the Arduino wasn't properly supplying 5 volts to the servo motor. The servo motor just acted tired. So we hooked it up to the power supply in the ECE labs, as you can see here, to supply a constant stream of 5 volts to the servo, which immediately fixed that problem. That's just one note that we wanted to note. As for overall system performance, our beam performed very well, very nominal. The only issue it had was when moving from the 9-inch mark to the 5-inch mark. It took an extra 8 seconds, as you can see, 28 seconds to get there. That is the only problem the beam had in the entire test. As for everything else, it worked perfectly nominal.